When we take wastewater and turn it into drinking water, that's where people are really concerned about pathogens making it into the finished product. And in that case, we over-engineer our treatment systems to guarantee that we're getting rid of the viruses. So the problem with over-engineering water is that it just costs more to treat. If we could measure viruses directly or more directly, then we wouldn't need to engineer our water as much, treat it as much. We could guarantee it was safe with less treatment. I've been working with viruses for about 10 years now, so I know a lot about virus structure and virus chemistry. With this knowledge, I feel like I'm in a good position to develop new technologies for detecting viruses in water. I picked these 3 technologies because each of the 3 is targeting a different problem in water quality engineering. These 3 technologies are all being applied in medicine, but hadn't been completely translated to water quality engineering, even though often we have the same problems. A lot of gastrointestinal illnesses originate from contaminated water. The first technology is using virus-like particles that have fluorescent tags to help us determine how many viruses are removed through treatment processes. The idea is that we'll spike these non-toxic particles in that don't have any genetic material, so they're not infectious. And then we can use flow cytometry to almost in near real time tell us how many viruses are being removed through each unit process. Right now, the methods that we use to do that are things like turbidity of the water or the conductivity of the water. And we can measure those things in real time, but they're actually very poor indicators of the viruses being removed. So the second technology is about detecting viruses in places where we don't have high-tech equipment. So you've probably heard about using CRISPR-Cas technology for gene editing, but it also can be used for detecting specific sequences of nucleic acids and then creating a signal to let you know that those nucleic acids are there. This has been established by a team at MIT in human samples. I want to use this technology to detect viruses in water. Almost like a pregnancy test where a piece of paper with a single line meant that the virus wasn't present and a piece of paper with 2 lines meant that the virus was present. There are a lot of viruses there. Many of them aren't human viruses. A lot of them are viruses that infect plants or bacteria or protozoa. And so this third part of our project is on pushing metagenomics forward for virus sequencing and getting a better handle on what all viruses are present. And ultimately, maybe we can actually harness these viruses and use them for good, help us purify the water. I really appreciate the Water Research Foundation granting me the Paul L. Busch Award. You know, it's an acknowledgement of the research that my team is doing and gives me the opportunity to explore new research directions that we otherwise wouldn't have the opportunity to do. As a researcher, that's really exciting. You know, I can see 30 years ahead in my career, and I don't think I'll ever run out of questions or applications of viruses.